Good morning. Today we'll have to discuss another topic of our statistics and probability, and this will be random sampling and sampling distribution. Here are the competencies that we need to master for this topic. First, we will try to illustrate random sampling. Second, distinguish between parameter and statistics. Third, identify sampling distribution of statistics, the sample mean. Then find the mean and variance of the sampling distribution of the sample mean, and we'll try to define the sampling distribution of the sample mean for normal population when the variance is known and unknown. The objectives of this lesson. First, we'll try to define random sampling. Next, describe different types of random sampling. Then we'll have to identify parameter and statistics. Then define sampling distribution, and lastly, solve mean, variance, and standard deviation of sampling distribution. Activity number 1, sampling. So in this activity, you will answer the question that follow after the given situation. So our situation here is, you need to select a random sample of 10 classmates to measure their weight. So our question, how would you select the 10 samples? So pause this video first and you will be given 5 minutes to answer.
A few moments later.
Welcome back, and now I guess you already have your answer about this activity number 1. So I could also share my answer for this activity. So in order for me to choose the 10 samples, I could have the method drawn by Lansorin. I will list all their names and then pick 10 names inside the box. So, how about you? What's your answer? And now let's have for our discussion. Random sampling. Random sampling is also known as the probability sampling and is a sampling method that allows for randomization of sample selection. So we use random sampling so that we will not be biased in selecting our samples. So the first type of random sampling, so there are 4 types of random sampling, and the first type is called the simple random sampling. It is a randomized selection of small segment of individuals, and the most common simple random sampling is drawn by lot. So, or Lotto type of sampling. The second type is the systematic sampling. It's selection of specific individuals. So here it's like similar to the simple random sampling, but it has a system to use. So example, you will try to count numbers 1 to 7, and then all number 1 will be group, all number 2, all number 3, and then after that you will select a group that will be your respondents. Then third example is the stratified sampling. Stratified is partitioning of a population into subclasses with notable distinctions and variances. In this way, you will try to group or form stratum or strata in your population. You could try group them according to age or according to gender or according to their um, height or weight. It could be according to their example favorite subject, like that. And then after that, after you group them according to their subclasses or stratum, you'll try to get some samples of each group, and then the new form group will be your sample. And the fourth type is called the cluster sampling. Cluster sampling is dividing a population into subclasses. It is somehow similar to stratified. So you group your, or you divide your population into groups. So it could be according also to age or gender. So after that, you will try to check whether which of the group has the highest number of samples, and then you select it as your the new sample group. And now let's have an example. So we have here a situation. A researcher wants to have 110 respondents to answer his survey form. His respondents are the senior high students of Kabangkalan National High School, and the school said to have 330 senior high students. How would he choose the 110 respondents? First, the researcher could use the simple random sampling, meaning he employed draw by lot in choosing 110 samples. So let all the senior high students write their name on a 1/8 crosswise sheet of paper. Then the students drop their piece of paper with their names on a box, and the researcher will pick 110 papers from the box. And the names of the students written on the papers that are picked by the researcher will be the respondents of the research. Understand? Is there any other way? Yes. Second method, the researcher could use the systematic sampling method. He listed down all the names of the students in alphabetical order. He then assigned the numbers with 1, 2, and 3, starting from the first listed name until the end. All the names with assigned number of 2 will be the respondents of the research. Wow, there's another method. Is there another one? Yes. Well, try to have the stratified sampling. So the researcher grouped the students according to age. Then he will pick number of students in each group or sort according to its size compared to the population. All students will be picked from each group will be the respondents of the study. So this is stratified. How about cluster? What if the researcher goes with cluster sampling? He grouped the students according to gender. He will pick the group with the highest number of students under a specific gender. If it's more than 110, then he will use simple random sampling among the group. So the 110 students that will be picked of the same gender will be the respondents of the research. So now, are you ready for our activity? Activity 2, sampling distribution. So now we move on to the second topic, the sampling distribution. So we have here a population consists of 5 numbers. Form samples of size 3 that can be drawn from this population and solve the mean of each group. So what we're trying to have here is to list down all the samples of size 3. When we say size 3, meaning you only to pick 3 numbers out of 5. So try to pick all the samples with the size 3. So try to list down all the combinations. So out of 5 numbers, we only pick 3. So pause first this video and try to answer. And I'll give you 5 minutes to do this.
A few moments later.
Welcome back. Do you already have your answer? So now let's reveal the answer for activity number 2. So we'll use the combination formula to find the number of possible groups that we can have in the size of 3 out of 5 numbers. And we got here 10. So there are 10 possible groups of size 3. So we try to list down all the 10 and the mean of each group. So group 1, we have here 2, 4, 6, and the mean is 4 because 2 plus 4 plus 6 is 12 divided by 3, and the answer is 4. Our second group is 2, 4, 8, and with a mean of 4.67. Our third group is 2, 4, 10 with a mean of 5.33. The same with our fourth group with a mean of 5.33. For our fifth group, we have 2, 6, 10. Sixth group, 2, 8, 10. Seventh group, 4, 6, 8. Eighth group, 4, 6, 10. Ninth group is 4, 6, 4, 8, 10. And the 10th group is 6, 8, 10. So I believe that you got all those 10 numbers or 10 groups, I mean, with their mean. Moving on, we have here the topic about sampling distribution of sample means. So when we say sampling distribution of sample means, it means that it is a frequency distribution using the means computed from all possible random samples of a specific size taken from a population. So steps in constructing the sampling distribution of means. So we have here step 1. We try to determine the number of possible samples using the formula, the combination formula. We have this one during our grade 10. Second is to list all the possible samples and compute the mean of each sample. And the third one is to construct a frequency distribution of the sample means obtained in step 2. So let's try to have an example so that we can understand better in how to construct the sample distribution of sample mean. Our example. So for example, we have a population consists of 5 numbers. This is what we had in our activity 2. Construct a sample distribution of samples mean of size 3. So again, we use the combination formula and there are 10 possible groups of size 3. And then we listed down the groups. And the third one is the frequency. So we can see there, group 1 has a mean of 4. So there's only one group that has a mean of 4. There's only one group also has a mean of 4.67. There are two groups, group 3 and group 4 have a mean of 5.33. There are two groups have a mean of 6, which is the group 5 and which are the group 5 and group 7. Two groups also have a mean of 6.67, group 6 and group 8. We only have one group that has a mean of 7.33, and one group has a mean of 8. So, very easy. So, that is how we try to construct our sample distribution of a certain sample size. Moving on, we have here population and sample. So when we say population is the totality of observations that we are interested to study or investigate. So example, the whole Philippines, we all have more than 100 million when we talk about our population. And when we measure population, we call it as parameter. So parameter is the measurement used in measuring population. And then we have sample. Sample is the finite number of objects selected from the population. So most of the surveys or most of the research, we only use sample. We only use sample in order for us to save money, time, and energy. Because if we will try to have a survey of more than 100 example, a survey in the Philippines, so we all have more than 100 million. And if we want to conduct the 100 million survey, so we'll have more time, more effort, and more money to use. So that's why in SWS survey, we do only use at most 2,000 or at least 2,000 sample. So when we try to measure sample, we use statistics, or statistics is the term used in measuring the sample. So for parameters and statistics, they use different symbols. So for mean, for parameter, we use the mu. For mean, for statistic, we use the x bar. So there's a bar above the x. For variance parameter, the symbol used is the sigma square. And for the variance of statistics, we use the s square. For standard deviation, we only use sigma. And for statistics, we use s. So we have here example of parameter and statistics. In a class of 50 students, the mean of age of 50 students, so you try to solve all the data in the class. But if you only have the age of the 10 students, that's an example of statistics. And we have there in parameter, we have the use of the different symbols in parameter and the different symbol used in statistics. So now let's have an example. A population of 6 numbers consists 3, 5, 6, 9, 11, and 14. Let's try to solve the mean of the 6 numbers. We will try to solve the standard deviation of the 6 numbers. Construct a sampling distribution of sample means of size 2 and compare the mean and standard deviation of sampling distribution to the mean and standard deviation of the population. Start for the first task. In order for us to solve for the mean of the 6 numbers, we'll just add them and then divide it by 6 because there are 6 numbers. And we got a mean of 8. So take note, we use the mu, the symbol for population. So set A, or the task for the first task, is about measuring the parameter. Then in order for us to get the standard deviation, we use this table. So this table is so familiar for you, to you because we have this one when we were in grade 7. So in order for us to get the variance, so first we subtract x to the mean, and then we have the perfect squares. So 3 minus 8 is negative 5, 5 minus 8 is negative 3, then 6 minus 8 is negative 2, 9 minus 8 is 1, 11 minus 8 is 3, and 14 minus 8 is 6. And then the square of each number is always positive. And then we add them, all the squares divided by 6 because there are 6 numbers there. And our variance is 14. And in order for us to get the standard deviation, it's just the square root of the variance. So our standard deviation of the population is 3.74. And for the sampling distribution, so we have here the use of the combination formula. So there are about 15 possible samples. And these are the 15 possible samples. So the 3 and 5, 3 and 6, 3 and 9, and so on and so forth with their possible or with their means. And then we will try to have the frequency distribution. There's only one group that has as a mean of 4. One group with a mean of 4.5. One group have a mean of 5.5. One group also has a mean of 6. Two groups have a mean of 7. Then one group has 7.5. One has 8. Only we have two groups have 8.5 as their mean. One group has a mean of 9.5. Two groups have 10. Then another one group has 11.5 and another one group of has 12.5. So now let's have letter D. This is the frequency table that we had in letter C. So in order for us to solve the mean, we just add the amount of 4 times 1 is just 4. 4.5 times 1 is just 4.5. And then we just multiply it to its frequency and then divide it by 15 because there are 15 possible results of samples. So the mean is 8. And then we have here the variance. Square of 4 plus square of 4.5 plus square of 5.5 plus square of 6 plus square of 7 times 2 because there are 7. Two groups have 7 as the mean. And then add them divided by 15 minus the square of the mean, and the variance is 5.6. So the standard deviation of our sampling distribution of sample size of 2 is 2.37. So let's compare it to the mean and standard deviation of the population. So the mean of the sampling distribution of sample means is equal to the mean of the populations. Yes, we have the same mean. How about the standard deviation? The standard deviation of the sampling distribution of sample mean of size 2 is smaller compared to the standard deviation of the population. Let's have our activity 3, parameter or statistics. So for our activity, we have to determine whether the numerical measure or measures is a parameter or statistic. For number 1, the school guidance counselor of Kabankale National High School is interested in the mean IQ scores of all senior high school students. From the record IQ scores of all students, she obtained a mean IQ of 105. Second, A math teacher wants to know the performance of his students in the first quarter examination in 5 different sections. He selected 2 sections and found out that the mean and standard deviations are 15.2 and 1.7 respectively. Third, a nutritionist wants to estimate the proportion of children below 10 years old who suffer from micronutrient deficiency. Only 115 children below 10 years old are examined out of 500. She found out that 65% of the examined children have micronutrient deficiency. So try to pause this video first and give your answer. So I'll give you 2 minutes to answer this one.
A few moments later.
Welcome back. I believe that you already have your answers. So let's try to check. Let's start with the first situation. Is it a parameter or statistics? Very good. It's a parameter. How about the second one? Very good. It's a statistic. How about the third one? What's your answer? Correct. It's a statistic. You got it all correct. Moving. Let's have activity 4, sampling distribution. So consider a population consisting 4, 7, 10, 13, 16, and 19, and construct the sampling distribution for the means of size 3 and solve the mean and standard deviation. So pause this video again and I'll give you about 10 minutes to answer. God bless.
A few moments later.
Welcome. I guess you already have the answers for activity 4. So now let's try to reveal our answer. So step 1 in constructing our sampling distribution, we have here the combination formula. So there are 20 possible combinations of samples of size 3 out of the 6 numbers. And then these are the 6 or the 20 groups of sample size 3 out of 6 numbers. So 4, 7, 10, 4, 7, 13, and with their means. So let's try to construct the frequency table we have here. So we have one group has 7, 1, 8, 2 groups have 9, 3 groups have 10, 11, 12, and 13. So 3 different groups, and then 2 groups have 14, and then 1 group have 15, and then 1 group have 16. So that is based on our step 2. And then for the mean, we just add them divided by 20. And then we have there 18, 7 plus 8 plus 18 because we have 2, 9. And then plus 30 because we have 3, 10. Then 3, 11 is 33. And then we got a mean of 11.5. And for our variance, 7 square is 49, 8 square is 64, 9 square is 81, multiplied to 2 is 162, and etc. So same process for the rest, and then subtracted to the square of our mean, and we have a variance of 5.25. And for our standard deviation, so easy, we just have the square root of our variance, which is 2.29. So you got it all. Wow, very good. So for our suggestions, comments, and queries, you can have your comment there in our comment section or directly ask me through Messenger. So thank you very much. See you next topic. Bye-bye.